So now we are at the point where we know what the loop invariant is, we know how we repartition the vectors to be able to move forward. The question now is, what state are we in terms of these pieces that we have exposed? Okay, so here I have repeated what's on the worksheet. And what do we know? Well, this is an indexing step. The contents of alpha don't change when we do this. So at this point, it's still the case that alpha is equal to x top transpose y top, the dot product of x top and y top, plus alpha hat. Okay? But notice that we have relabeled x top x0 and y top y0. So in terms of how we now label these pieces, our loop invariant is still true, but we can express it in terms of these exposed parts of x and y by saying, oh, just do a textual substitution, just replace everywhere where you see x top and call it x0 instead. Alright, so here now we have the state of alpha in terms of the exposed pieces in the vectors x and y. And what do we do with that? Well, we fill it in. Here, alpha, we know now, is equal to x0 dot product with y0 plus alpha hat. And this is actually a good moment to focus where this loop guard here comes in, the fact that that's still true. What this here tells us is that the top part of x is less than all of x. And notice that it's that allows us to say, oh, we split off the top element of the bottom part of x because we know that the bottom part of x is not empty, and similarly that the bottom part of y is not empty. So this part actually is very important to allow this step to move forward, for this to be a legal operation. Otherwise we wouldn't be able to necessarily do that.